Hello all, I am Hemant Kumar from the Department of Computer Science and Engineering. So I am here to present the my mini project titled Pneumonia Detection using Fast AI and MATLAB. This project focuses on using deep learning techniques to automatically detect pneumonia from chest X-ray images and also provide visual interpretation using MATLAB. Agenda. In this presentation, I will cover the following points: introduction, problem statement, scope of the project, methodology, system architecture, algorithms used, implementation and code, results, conclusion and future work, and references. So, um, w- let's move on to the introduction. Pneumonia is a serious respiratory disease that affects the lungs and can be fatal, especially in children and elderly people. It causes inflammation in the air sacs of the lungs, which may fill with fluids or pus. According to the World Health Organization, pneumonia is one of the leading cause of death among children under 5 and is still a major health issue worldwide. Early diagnosis is very important to reduce complications and mortality. However, diagnosis is very important to reduce complications and mortality. Manual diagnosis using chest X-rays is time consuming and depends heavily on expert radiologists. So, this project aims to automate pneumonia detection using deep learning or faster and more accurate diagnosis. So let's move on to the statement of the problem. The traditional pneumonia diagnosis process faces several challenges. First, diagnosis pneumonia using chest X-rays is a time-consuming process. Second, interpretation of X-rays can be subjective, meaning different radiologists may give different opinions. Third, many hospitals, especially in rural areas, lack access to expert radiologists. Because of these challenges, there is a need for an automated, reliable system that can assist doctors by quickly predicting pneumonia from X-ray images. The objective of this project is to build an AI-based pneumonia prediction system that is accurate, efficient, and easy to use. So let's move on to the scope of my project. The scope of this project includes developing a deep learning model that can classify chest X-ray images as normal bacterial pneumonia or viral pneumonia. The project focuses on improving the speed and accuracy of diagnosis. It is mainly intended for medical professionals and healthcare institutions. The deliverables include a trained machine learning model, a prediction workflow, and proper documentation. However, this project does not cover real-time monitoring system and does not replace medical experts. It is designed as a decision support tool. Now let's move on to the methodology I have used here. The methodology of the project consists of five major steps. First, data collection. Data collection is the first step and is done using publicly available chest X-ray datasets from Kaggle. Secondly, data preprocessing is performed to improve image quality. This includes resizing images, enhancing contrast, and reducing noise. Third, a convolutional neural network model is developed using fast AI and Restnet 50 with transfer learning. Fourth, the pre-trained model is integrated to predict pneumonia from new X-ray images. Finally, MATLAB is used for visualization and interpretation of the prediction results, which helps doctors understand affected lung regions. Now, let's move on to the architecture diagram. This slide shows the overall system architecture. This slide shows the overall system architecture. First, the X-ray image is given as input. Next, the image is preprocessed to improve quality. Then the image is passed to the fast AI ResNet 50 model for classification. The model predicts whether the image is normal, bacterial, pneumonia, or viral pneumonia. Finally, MATLAB visualizes the result for better interpretation. Now, let's move on to the design diagrams used. So, the first one is the use case diagram. The use case diagram represents how the user interacts with the system. The user uploads a chest X-ray image and receives the prediction result. Now, let's move on to the class diagram. Class diagram represents the X-ray image dataset and model components via the class diagram. Then let's move on to the sequence diagram. The sequence diagram shows the flow of data from image upload to prediction and visualization in a sequential manner. These diagrams help us to understand the system design clearly. Now let's move on to the algorithm I have used here. The main algorithm used in this project is Restnet 50, which is a deep convolutional neural network with 50 layers. Restnet 50 uses residual connections which help avoid the vanishing gradient problem and allow deeper networks to train effectively. Since ResNet 50 is pre-trained on ImageNet, we use transfer learning, which reduces training time and improves accuracy. This model is very effective in identifying subtle patterns in chest X-rays images, making it suitable for pneumonia detection. Now let's go on to the implementation. So here I have just stated what I have done in the Python code